In today's lesson, we're going to be looking at the selection sort technique. So we're going to be using arrays, so that means we need to import java.util.arrays. All right, so selection sort. It works by finding the smallest or largest element and switching its place with the element in the first or last place. The sort continues in this fashion until the elements are all in the correct place. Now, I stated it works with the smallest or largest element, switching it to the first or last place. It depends on how you want to sort it. Do you want to sort it by finding the smallest, putting it into the first place, or do you want to find it by finding the largest, putting it into the last place? It's up to the user exactly how they want selection sort, but the concept of how it works remains the same regardless which way you do it. All right, so let's look at this example here. We've got this array. As you can see, it is not quite sorted, 3, 5, 12, 0, 4, 9. So the first pass, the smallest element is 0. So the 0 and 3 switch places. Then the next smallest is 3. So the 3 and 5. Then the 4, so the 4 and 12. The 5 is actually in the correct place. It ends up swapping with itself. And the 9 and 12 are need to swap. And you're done. So now we're going to test this out. So we have our array here. We're going to print it that's unsorted. We'll send it to selection sort. We'll print out the sorted one. And we're also going to compare, we're going to print out how many comparisons it took and how many swaps. That's what our method selection sort returns as an array, is how many comparisons and swaps it takes. So let's run through this and let's see what happens. So selection sort takes a collection, sorts it. It takes as a single parameter an array, and what it's going to return is how many swaps and comparisons it is as an array. So it's going to index 0 is going to be the number of comparisons, index 1 is the number of swaps. The reason we're doing that is this is going to allow us to determine how efficient our sorting technique is. The less comparisons and the less swaps it takes, the more efficient it will be. So, selection sort. So we've got our comparison swap array, initializes 0, 0. It's I, j, smallest, and temp, a bunch of variables. So we're going to reverse it, going through from 0 to the array length. So what we're going to do is we're going to initialize smallest to I. In other words, we're going to say, hey, whatever that's at I is currently the smallest. And smallest is going to refer to an element. Now we're going to look for what is actually the smallest between I and the length of the array. So every single time this runs, we're going to increase the number of comparisons. Because look, we're doing an if statement. We're comparing our elements. So we're going to look at, is index j smaller than index smallest? If that's the case, I found something smaller than what's at smallest. Therefore, I need to change smallest to j. Now, once this loop here is done, I have found the smallest element in our array. Thus, I need to swap them. I increase my number of swaps, and then I swap here my smallest index and my index I. So I perform a swap. And then this for loop runs again. So once that's run the first time, index 0, whatever is there, is now in the correct place. So now I is 1. It's going to perform the same thing. So the front of the array, index 0, is going to be sorted. Then it's going to be index 0 and 1, then index 0, 1, 2. So the front of it's constantly being sorted, putting the smallest in its correct place. And that is done. That's how selection sort works. Now what we're going to do, we're going to create an array, and we're going to do this slightly different method called selection sort show swap. This is going to show the swap every single step. So that means we're actually going to be able to see this sort of idea, showing every single pass. So in that method, the only difference is I added this print statement. It shows that a swap occurred and pre-prints the array. All right, so let's go and let's run it and let's see what this looks like. So our unsorted and then our sorted took 21 comparisons, 6 swaps. Now, these are going to stay constant. Watch, let's do it again. It's always going to have the same number of comparisons and the same number of swaps, because selection sort always performs the same thing no matter what. So if I change up my array, it's still going to have the same number of comparisons, same number of swaps. So it's always doing the same amount of traversing. It's always performing the same number of swaps. All right, so let's look at what happens. We can actually see every single swap. Look, 3 and 0, they swapped. 5 and 3, they swapped. 4 and 12, swapped. 5 swapped with itself. 9 and 12 swap. And then 12 swaps with itself. And that is how selection sort works. And that's the end of this lesson.